Hello everyone, myself Hanasha. So today we are going to study a topic from complex numbers. So let us define logarithm of a complex number. If z and w are two complex numbers and z is equals to e raised to w, then we can write w as what? Log z. So this is called the logarithm of a complex number z. Now let us suppose z as x plus iy. So this can be written in the exponential form as r into e raised to I theta, wherever r is equal to modulus of z, that is equals to square root of x square plus y square, and this theta is equals to argument of z, that is equals to tan inverse y by x. Okay, so log z, we can apply log on both the sides. So log z is equals to log r into e raised to I theta. Now we know log a is equals to what? Log a plus log b. So this can be written as log r plus log e raised to I theta. This can be further simplified as log r plus I theta times log e. This will come on this side using the formula log a raised to b is equals to what? B log a. Okay. So now log e is 1. Log e to the base e is what? 1. So finally log z formula is log r plus I theta, which you have to remember, that is log z is equals to log r plus I theta. Right, where r and theta formulas you already know, they are this. Okay, now we can further simplify this as put the value of r, that is square root of x square plus y square, and value of theta is tan inverse y by x. Now this can be further written as x square plus y square raised to half. So final simplification of log z, that is equals to log x plus iy is equals to 1 upon 2 log x square plus y square plus I tan inverse y by x. And this is called the principal value of log x plus iy. Now let us study how to find the general value of log x plus iy. So it is denoted by capital log x plus iy, and that is equals to log r plus. Whenever I want to find general value, I have to add 2 and pi, right? So plus I times 2 and pi plus theta. Right, now let us put the value of this r. So r is what? Square root of x square plus y square, which can be written as x square plus y square raised to half. So this log r is finally 1 upon 2 log x square plus y square plus I times 2 and pi value of theta, that is what? Tan inverse y by x. Now we will keep these 2 and pi I aside, and remaining things is what? Our log z, that is small log z or log x plus iy, right? So capital log z formula is what? 2 and pi I plus small log z, and where our small log z is this. Okay, so the general value of log x plus iy is denoted by what? Capital log x plus iy, right? And to distinguish it from its principal value, which is denoted by small log x plus iy. So we are using such notation, right? Okay, so now let us study few examples. So for the principal branch, show that log of I cube is not equals to 3 log I. So we have to find the principal values of both of these and check that it is not equal. So let us start with the LHS. That is, we have to find the principal branch of capital log of I cube. That is, I want to find small log I cube. Okay, so this can be simplified as what? Log of I square into I. Now we know the value of I square, that is what? Minus 1. So we have to find log of minus I, right? So your z is what? X plus iy, which is equal to minus I. So your value of x is 0 and y is minus 1. So now first find the values of r and theta. So r is equal to square root of x square plus y square, that is equal to 0 square plus minus 1 square. So the value of r is 1. Now x is 0 and y is less than 0. So this lies in the fourth quadrant, right? So the value of theta can be obtained using the formula minus tan inverse mod y by x. So it will be minus tan inverse infinity, right? So this will be equals to minus pi by 2. So now the answer of log of minus I is equals to, using the formula, we have to apply the formula log r plus I theta, right? Now put all the values, value of r is 1, but log 1 is 0. So only what will be the answer? I pi by 2. So this is the answer of LHS. Okay, that is minus I pi by 2. Okay, so now let us find the RHS. That is, we have to find the value of principal branch of capital log I. So we have to find the value of log I. Now here you can see x is 0, y is 1, right? Because z is I. So your r will be 1 and theta. This lies in the first quadrant. You can see both are positive values. So it lies in the first quadrant. So theta will be tan inverse what? Y by x. Okay. Now put the values of y and x, so it will be tan inverse infinity, so answer will be what? Pi by 2. So answer of RHS, that is answer of small log I, will be equals to log r plus I theta. But our value of r is 1, so log 1 will be 0, theta is what? Pi by 2. So answer is what? I pi by 2. Okay, so from this, and we have what in between? Here we also have 3 log I, right? So here we have to multiply by 3. So the answer of the RHS is what? 3I pi by 2. So from this we can say that LHS is not equal to RHS. Okay. So now let us study one more example from this. We have to find the value of minus I raised to I. So what would be substituting Z as minus I raised to I? Now let us take log on both the sides. Therefore log Z is equals to I log of minus I. Now I want to find this log of minus I. So from this we can say that x is 0, y is what? Minus 1. So r will be what? Square root of x square plus y square. So answer is 1. Now this is less than 0, so this lies in the fourth quadrant, right? So value of theta will be what? Minus tan inverse mod y by x. So we will have tan inverse infinity. So answer will be minus pi by 2. Okay. So now if you want to find the value of log of minus I, the formula is what? Log r plus I theta. So now put the values of r and theta. So you will get I times. Now log 1 will be 0. So just put the value of theta. So it will be minus I pi by 2. Now open the bracket. So it will be minus I square pi by 2. Value of I square is what? Minus 1. So what will remain? Pi by 2. So log z is equals to what? Pi by 2. Therefore z is equals to e raised to pi by 2. Therefore your value of minus I raised to I is equals to what? E raised to pi by 2. Okay. So now let's go to the next example. Find and plot all the roots of log z is equals to I pi by 2. So we have to first find the roots and then plot in the Argand's diagram. So now firstly from this we can say that z is equals to e raised to pi by 2. Now using Euler's formula, you know e raised to I theta is what? Cos theta plus I sin theta. So modify this accordingly. So therefore your z will be cos pi by 2 because theta is pi by 2 plus I sin pi by 2. Now we know the value of cos pi by 2 is 0, sin pi by 2 is 1. So final answer of z is what? I. Compare this with x plus I by. So your x is what? 0, y is 1. So your point P of x comma y is equals to P of 0 comma 1. Now just plot this in your Argand's diagram. Okay, so this is x-axis, this is y-axis, this is real axis, right? This is called imaginary axis. And now just plot this point P of 0, 1 which will lie over here, right? So this is our diagram. Okay. So now let us go to one last example. So we have to find all solution of sin z is equals to 2. Okay. So now we know the formula of circular function sin z. So let us use that formula, that is 1 upon 2 I e raised to iz minus e raised to minus iz equals to 2. Now let us take 2I on this side. Therefore, e raised to iz minus e raised to minus iz is equals to 4I. Now take out e raised to minus iz common. So we will get e raised to 2iz minus 1 is equals to 4I. Now take this on this side. Therefore, e raised to 2iz minus 1 is equals to 4I e raised to iz. Now bring this on this side to form a quadratic equation. Therefore, e raised to 2iz minus 4I e raised to iz minus 1 is equals to 0. Now, in order to find the roots of this equation in the form of e raised to iz, we will apply the formula minus b plus or minus under root b square minus 4ac upon 2a. So from here you can see the value of a is 1, b is minus 4I, and the value of c is what? Minus 1. Put all this value in this. Therefore, your e raised to iz is equals to b is what? Minus 4I. So here it will be plus 4I plus or minus under root of minus 4I whole square. It will be 16I square minus 4 into 1 into minus 1. So plus 4. Okay. Upon 2. Now let us simplify this. We know the value of I square, that is minus 1. So we will get 4I plus or minus 16 plus 4. So under root of minus 12 upon 2. Furthermore, if I simplify this, 12 can be written as what? Plus or minus 2 root 3I. Because we have minus also, so I will come upon 2. Okay. Therefore, e raised to iz will be equals to, just take out the 2I common from the numerator. So 2I common, inside we will have 2 plus or minus root 3 upon 2. Now 2 and 2 will get cancelled out. Therefore, e raised to iz is equals to what? I into 2 plus or minus root 3. Okay. So now let us find the value of iz. So it will be ln I into 2 plus or minus root 3. Now we know ln AB is equals to ln A plus ln B. So using this, it will be ln I plus ln 2 plus or minus root 3, right? And here we have iz. So now let us bring this I on this side. So it will be z is equals to 1 upon I into ln I plus ln 2 plus or minus root 3. Now multiply and divide by I. So in denominator we have I square, which is equals to minus 1. So final value of z is what? Minus I times ln I plus ln 2 plus or minus root 3. So now our task is to find only the value of ln I using the formula of log z, right? So now first let us find the value of ln I. So here x is 0, y is 1. So r we can find using x square, square root of x square plus y square. So r will be 1. And this lies in the first quadrant, right? So you can find the value of theta using the formula tan inverse mod y by x. So that will be tan inverse infinity. So answer is pi by 2. And the formula of log z is what? ln r plus I theta. Just put the values of r and theta. R is 1, so log 1 will be 0. So answer is what? I pi by 2. Okay. So final value of this z, that is all the roots of sin z, will be equals to minus I times, answer of ln I is what? I pi by 2 plus ln 2 plus or minus root 3. Right? Now because sine is a periodic function, right? that is sine 2n pi plus or minus theta is equals to sine theta, right? So what we will write our final answer z as minus I into I pi by 2 plus ln 2 plus or minus root 3 plus or minus 2n pi, right? So this is our required answer. Okay, so I hope you understood throughout the session. Thank you for watching.